Max Planck, 1858 to 1947, was a German physicist who is best known for his contributions to quantum theory. In 1900, Planck proposed that energy was not continuous, but rather it was made up of discrete packets called quanta. This idea revolutionized the field of physics and laid the foundation for the development of quantum mechanics. Planck was also a pioneer in the study of blackbody radiation, which is the electromagnetic radiation emitted by an object due to its temperature. His work in this field led to the development of Planck's law, which describes the spectral distribution of blackbody radiation. In 1905, Einstein published a paper titled, "On a Heuristic Viewpoint Concerning the Production and Transformation of Light," which provided an alternative explanation for the photoelectric effect. He described a beam of light as a group of discrete particles, now known as photons, rather than a continuous wave. Regarding Planck's earlier discovery of the Planck relation in blackbody radiation, Einstein offered another interpretation, that a photon with frequency v has energy equal to h times v, where the h factor is Planck's constant. Einstein believed that each quantum comprising the beam of light possessed energy equal to the frequency multiplied by Planck's constant. In early 1913, by examining spectroscopic data, Bohr wrote a lengthy treatise titled, "On the Constitution of Atoms and Molecules," which proposed quantum discontinuity and successfully explained the structure and properties of hydrogen and hydrogen-like atoms. Bohr proposed the Bohr model of atomic structure. According to this model, electrons orbit the nucleus in orbits, with outer orbits capable of accommodating more electrons than inner orbits. The number of electrons in the outermost orbit determines the chemical properties of the element. If an electron from the outer orbit falls into an inner orbit, it will release a photon with a fixed energy. By introducing quantization conditions, Bohr proposed the Bohr model to explain the hydrogen atom spectrum. He also introduced the complementary principle and the Copenhagen interpretation to explain quantum mechanics. He was also the founder of the Copenhagen School and had a profound impact on the development of physics in the 20th century. In early 1913, by examining spectroscopic data, Bohr wrote a lengthy treatise titled, "On the Constitution of Atoms and Molecules," which proposed quantum discontinuity and successfully explained the structure and properties of hydrogen and hydrogen-like atoms. Bohr proposed the Bohr model of atomic structure. According to this model, electrons orbit the nucleus in orbits, with outer orbits capable of accommodating more electrons than inner orbits. The number of electrons in the outermost orbit determines the chemical properties of the element. If an electron from the outer orbit falls into an inner orbit, it will release a photon with a fixed energy. By introducing quantization conditions, Bohr proposed the Bohr model to explain the hydrogen atom spectrum. He also introduced the complementary principle and the Copenhagen interpretation to explain quantum mechanics. He was also the founder of the Copenhagen School and had a profound impact on the development of physics in the 20th century. In 1923, Louis de Broglie published 3 papers on waves and quantum mechanics in the Proceedings of the French Academy of Sciences. The first paper, entitled "Radiation, Waves and Quanta," proposed that material particles have wave-particle duality, suggesting that there is a sinusoidal wave corresponding to the moving particle, with both maintaining the same phase. Later, he referred to this hypothetical non-material wave as the phase wave. De Broglie did not explicitly introduce the concept of a matter wave here. Rather, he used the concept of phase waves or wave of phase, suggesting the existence of a non-material wave. The concept of matter waves was later introduced by Schrödinger when he established the Schrödinger equation and interpreted the physical meaning of the wave function. Erwin Schrödinger was an Austrian physicist, one of the founders of quantum mechanics, and a developer of molecular biology. He earned a PhD in philosophy from the University of Vienna and served as a professor at the University of Zurich, the University of Berlin, and the University of Graz. He worked in the Theoretical Physics Research Group at the Dublin Institute for Advanced Studies for 17 years. Schrödinger and Paul Dirac jointly won the Nobel Prize in Physics in 1933 for their development of atomic theory. He also received the Max Planck Medal in 1937. Building upon Louis de Broglie's theory of matter waves, Schrödinger established wave mechanics. The Schrödinger equation, which he established, is the fundamental law that describes the motion of microscopic particles in quantum mechanics, similar in its position in quantum mechanics to that of Newton's laws of motion in classical mechanics. Schrödinger proposed the Schrödinger's cat thought experiment, attempting to demonstrate the incompleteness of quantum mechanics under macroscopic conditions. Werner Karl Heisenberg was a famous German physicist, a primary founder of quantum mechanics, a representative figure of the Copenhagen School, and a recipient of the Nobel Prize in Physics in 1932. Quantum mechanics is one of the most important achievements in the history of science, and his book, The Physical Principles of the Quantum Theory, is a classic work in the field of quantum mechanics. Heisenberg was one of the most productive scientists after Einstein. Just as Einstein was inspired by Planck's quantum theory to propose the hypothesis of light quanta, Heisenberg was also inspired by Einstein's theory of relativity and established matrix mechanics in 1925, and proposed the uncertainty principle and matrix theory. Paul Dirac was a British theoretical physicist and one of the founders of quantum mechanics, making significant contributions to the early development of quantum electrodynamics. He held the Lucasian Chair of Mathematics at the University of Cambridge and spent the last 14 years of his life at Florida State University. In 1925, Werner Heisenberg proposed a theory focused on observable physical quantities, which involved the noncommutativity of matrix multiplication. He realized the significance of this noncommutativity and found similarities between Poisson brackets in classical mechanics and the matrix mechanics rules proposed by Heisenberg. Based on this discovery, he developed more explicit rules for quantization, known as canonical quantization. This work was published in a paper titled Quantum Mechanics in 1926, for which Dirac obtained his Ph.D. Dirac continued his research on quantum mechanics and developed a general theory that included both wave mechanics and matrix mechanics. Richard Feynman was an American physicist, educator, and writer, considered one of the most influential theoretical physicists of the 20th century. Feynman made outstanding contributions in physics, mathematics, and philosophy. One of his major contributions was the development of the theory of quantum electrodynamics, which explains the behavior of the microcosm. He was awarded the Nobel Prize in Physics in 1965 for this work. Feynman also made significant contributions to particle physics and cosmology, such as in the development of quantum chromodynamics. His contributions also included the introduction of Feynman diagrams as a tool for studying high-energy physics processes.